1. The point B, -2, -4, sorry. The point B, -2, -4, is on the terminal arm of an angle theta in standard position. A, determine the primary trigonometric ratios of theta, and B, determine the measure of theta to the nearest degree. First things first, let's draw a picture of this. It's the loveliest picture you'll see all day. So we have -2 and -4. So we know that this is in quadrant 3. So what we need to do to find out what our trigonometric ratios are, okay? We know that cos theta is x over r, sine theta is y over r, and tan theta is y over x. So we know what x is, right? -2. Awesome. We know what y is, -4. Awesome. What do we need to figure out? That's right. We got to find out that we have to figure out what that r is. So we know that r, using our formula from before, r equals the square root of x squared plus y squared. R equals x is -2 plus -4 squared. R equals 4 plus 16. R equals the square root of 20. But since we're in pre-calculus, we know how to simplify that. R equals 2 root 5. Awesome. So now, wherever I see x, -2. Wherever I see y, -4. Wherever I see r, all I have to put in is 2 root 5. So cosine is -2 over 2 root 5. Now see how we can simplify that? I know that 2 goes into itself one time, so it's actually -1 over root 5. My y is -4, so we get -4 over 2 root 5. 4 goes into itself, 2 goes into 4 2 times. So we have -2 over root 5. I'm not going to be super anxious about rationalizing the denominator. If we wanted to rationalize the denominator, then we would multiply both the numerator and the denominator by root 5. So then you would have -2 root 5 over 5, just so we don't have that root in the denominator. But guys, it's all right. If you can do this, I'm fine with that. Now this one's the easy one. We have y is -4, and we have x being -2. So we know that cos is just plain 2. -2 goes into -4 2 times, exactly. Okay, so that's our A. Lovely, done, check mark. What did we do again? We used the formulas here to fill in the gaps. The only thing that we were missing was that r, so we used Pythagorean theorem to solve for r. So for example, we take our x and we put -2, y -4, and wherever we see r, we put in 2 root 5. B, determine the measure of theta to the nearest degree. Now here's the secret with B part. We've been given our x, we've been given our y, but we had to do some fancy footwork to figure out what our r is. What happens if we messed up here? It means that cosine will be affected, sine will be affected, but tan won't be, because we've been given our y, okay, -4, and we've been given our x. So, I mean, what we can do is we can say, okay, yeah, inverse cos, cos to the -1, that's cos inverse. Cos inverse -1 over 5 is going to give us the right answer. Same with sine, sine inverse negative 2 over root 5 is going to give us the right answer. But we will be certain that no matter what, we're going to get the right answer if we do tan inverse tan inverse 2. Why is that? Because we've been given this information. We haven't actually done anything mathematical to it. Now, I know that these are right because I'm a math teacher and I know that I calculated the R value right. But to be certain that we get the right answer for this, I want to do 2. So we go tan inverse, so tan negative 1, 2 equals, when you punch that into your calculator, you're going to get a number like 243 degrees. In the next example, we're going to show that certain trigonometric ratios are going to have more than one answer. Okay, so but the reason why this one doesn't is because we know that the terminal arm, or the point at the end of the terminal arm, is in quadrant 3. So there can actually only be one answer. And when we look at this here, 243, is that in quadrant 3? Yeah. If you get this type of question and you get like 47 as your degrees or as your theta, we got some problems there, okay? But since it matches the correct quadrant, we're good.